Okay, so today we're going to be taking a deep dive into intelligence testing.
Sounds good.
And the paper you sent over is really fascinating. It's called Playing Statistical Ouija Board with Commonality Analysis.
Right.
Good questions, wrong assumptions.
Yeah.
And it's all about trying to measure intelligence.
Yeah, and specifically sort of this fundamental question in intelligence research of
Yeah.
can we separate like a general intelligence or this G factor
Right,
from specific abilities?
right.
Like, is
Well,
it...
are you just smart?
Yeah, are you just smart?
Or are you good at math
Yeah.
and bad at verbal reasoning?
Exactly. And this paper is kind of arguing that the way that we've been trying to do that might be flawed.
So it's like we're kind of getting a distorted picture of
Yeah.
intelligence.
Exactly. And so it uses this statistical method called commonality analysis.
Okay.
And commonality analysis is
And
basically...
can you break down what commonality analysis is?
Because it basically...
That sounds pretty complicated.
It sounds complicated, but it's actually fairly simple.
Okay.
So imagine you're trying to understand what makes a great athlete.
Okay.
Is it their overall athleticism?
Right.
Or is it like specific skills like their speed or their strength or their agility?
Right.
So commonality analysis is trying to separate those unique skills from just like general athletic ability.
Got it.
And we can apply the same thing to intelligence research.
Okay, so they're using this.
Yeah, so researchers have used commonality analysis to try to say, okay, how much of people's performance on intelligence tests is due to this G factor?
Right.
And how much of it is due to these like more specific abilities?
Yeah, so this person is, like I said, good at math, maybe not so good at verbal.
Yeah.
And we can see how much is G, how much is...
Exactly. And this paper is basically arguing that commonality analysis might not be a good way to measure G.
Okay.
So they use these computer simulations to show that even when G is the only thing influencing the data, like you can still get a small estimate for G.
Mm-hmm.
So it's kind of like saying, even if you knew for a fact that a cake was only made with flour, sugar, and eggs,
Right.
your analysis might tell you that flour doesn't contribute much to the final product.
It doesn't make any sense.
Yeah, and that's exactly what the paper is trying to point out.
Wow.
They give the specific example of this simulated data set called the Spearman data set, where G is literally the only thing that's influencing the data. But when you run it through a commonality analysis, you get this tiny estimate for G.
So then how can we trust like the results that we're getting from these...
That's a great question.
From these tests of...
And that leads to, I think, one of the biggest points of this paper is that a lot of what we're attributing to like these unique cognitive abilities might actually just be like limitations in our measurement.
Oh, so it's not that it doesn't exist. It's just
it might
that we're not measuring it correctly.
Yeah.
Interesting.
They suggest that like the size of these unique components in these intelligence tests might actually be more a reflection of how reliable the test is than like actual unique abilities.
So a test that's not very reliable.
Yeah, if you have a test that's not very reliable, it might look like there's less G.
Right.
When really there's not.
It's just that the test itself is not very good.
Exactly.
Wow. So it's almost like the measuring is distorting our understanding.
Yeah, I think that's a great point.
Right.
It's like by trying to measure it, we're actually changing it.
Okay.
And that leads into some really interesting questions. Particularly when you think about how intelligence tests are used in real-world settings.
Well, that's a perfect segue to the next part of the paper, which is talking about full-scale IQ.
Right.
Or FS IQ.
Yeah.
And whether it's biased against children with learning disabilities.
So
this is a big one.
Yeah, this is a really important topic. And the paper kind of dives into this by pointing out that kids with learning disabilities tend to have lower scores on measures of academic achievement, even when their FSIQ scores are similar to kids without learning disabilities.
So that does sound like a bias.
So on the surface, it does seem like there's some kind of bias there.
Yeah.
But the paper also points out that this might just be a reflection of how learning disabilities are defined. So if a learning disability, by definition, means that there's a discrepancy between a kid's kind of overall cognitive ability and their academic achievement, then the FSIQ might just be accurately reflecting that.
Right. So if it's in the definition already, then it's not really a bias. It's just doing what's there.
It's just kind of confirming that definition.
Okay. Interesting.
And this leads to a discussion of what's called slope bias.
Okay.
Which is basically asking...
What is slope bias?
Yeah, so slope bias is basically asking, does the relationship between FSIQ and academic achievement look different for kids with and without learning disabilities?
So it's trying to see if FSIQ is equally predictive in both groups?
Does it predict equally well for both groups?
Got it.
And the paper actually found no slope bias, which suggests that the relationship between FSIQ and academic achievement is similar for both groups of kids. It's just that maybe the starting point is different. So
so it predicts the same, but the levels are different.
Exactly.
Got it.
And that actually brings us to another interesting point the paper raises, which is the idea of profile variability and the G factor.
Okay, what do they mean by profile variability?
Yeah, so profile variability basically refers to the idea that some people have very consistent cognitive profiles. So they're good at everything, whereas other people are more variable. So they have strengths in some areas and weaknesses in others. And this paper takes a look at this previous study that compared the G factor in kids with flat profiles versus kids with more variable profiles.
Interesting,
And what they found...
And what did they find?
...is they found a smaller G factor in the group with variable profiles. But this paper is arguing that that might be a little misleading. They're basically saying it could just be a statistical artifact. Almost like saying tall people are taller than short people.
Wait, how is that?
Yeah, it seems kind of obvious.
How is that the same as G?
Yeah, so think about how they divided the groups. By definition, the group with variable profiles is going to have less shared variance across their abilities. And that shared variance is what contributes to a strong G factor. So it's almost like...
So it's just built in.
Yeah, it's almost built into the way that they form the groups. So it's not necessarily that these kids with variable profiles don't have a G factor. It's just that the way they were grouped makes it statistically harder to find.
Got it. So the way that they set up the study makes it harder to find.
Exactly. And this really ties back to, I think, this bigger point the paper's trying to make about we need to be really careful about how we're interpreting these statistical findings.
So we can't just blindly trust the numbers.
Exactly. And that leads us to, I think, the final critique in the paper, which is about this concept of low tolerance in statistics.
Which sounds low tolerance.
Yeah, it sounds very technical.
Yeah, and why should we care?
But it's actually pretty important. So it comes up a lot when researchers are using this technique called hierarchical regression. And hierarchical regression is basically used to see if different cognitive abilities have unique predictive power above and beyond what the overall G factor can tell us.
So it's like trying to figure out if being good at math actually matters for success in college.
Exactly.
Even
after we account for
that's smart overall.
Yeah, even after we account for G.
Yeah,
But here's the catch. When the things that we're using to predict, so in this case, the different cognitive abilities are really highly correlated with each other, it becomes really hard to interpret the results of these hierarchical regressions. And that's the problem of low tolerance. It's kind of like if you were trying to figure out the unique contributions of flour, sugar, and eggs to a cake when they're all mixed together. It's really hard to pull them apart.
You can't isolate them.
Yeah, you can't really isolate the effects.
Got it.
And the paper argues that while we should definitely be cautious when dealing with low tolerance, the order that you enter variables in these hierarchical regressions isn't always arbitrary. It can actually be used to test specific hypotheses, but it has to be done thoughtfully.
So it's not that it's bad. It's just we have to be careful with it.
It's just another tool that we need to be aware of.
Well, I think all this leads to this bigger question of how should we be thinking about intelligence? Are we measuring the right things?
I think that's a great question. And I think one of the things that this paper is really calling for is a more nuanced and careful approach to how we study intelligence.
It's like we need to be
we can
more critical of the statistics.
Exactly. We need to really think about what they mean.
Well, this has been a really fascinating deep dive.
Absolutely.
I'm really enjoying this.
Yeah, me too. And there's a lot more to unpack. So.
Yeah, there's a lot more to talk about.
Let's keep going.
Okay, let's do it.
With part 2. Okay, sounds good. I think one of the key things this paper highlights is the importance of considering alternative theories of intelligence.
Oh, okay.
So, for decades, like G has been this dominant model.
Right.
But there are other perspectives out there, like multiple intelligences.
Oh, yeah.
Or the triarchic theory of intelligence.
I remember learning about those.
Yeah.
In my psychology classes.
Yeah. And I think what this paper is kind of hinting at is that maybe it's time to revisit some of those.
Go back and look and see if they...
Yeah, and see if they can kind of fill in some of these gaps that we're not really able to explain with just G.
Because G is not really doing a good enough job.
Yeah, and maybe there's something more to this story.
Got it.
And another important tool, I think, is just methodological rigor.
Okay.
So this paper really underscores the need for, carefully designed studies, appropriate statistical methods.
Right. Using the right tool.
Yeah. And a healthy dose of skepticism.
When
we're interpreting the results.
So don't just believe everything you read.
Exactly. Question everything.
Okay.
And actually, speaking of oversimplification,
Yeah.
this paper provides a great example of that.
Okay.
With its critique of how some researchers have used commonality analysis to compare the G factor in different groups of children.
Oh, you're talking about the kids with the flat profiles versus the variable profile.
That's the one.
Okay, yeah.
And as we talked about earlier, that study found a smaller G in the group.
Right.
With more variable profiles.
Right. And they were saying that that's misleading.
But this paper is arguing that finding might be more about how the groups were defined.
Right. Because if they're variable, by definition, there's less shared variance.
Exactly.
And shared variance is what makes G.
Yeah.
So it's kind of like
almost like
built in.
Yeah, it's built into the way that they created the groups.
Yeah. So the study design is influencing the results.
Exactly.
Yeah.
And this is like a crucial point, I think, for anyone trying to understand research on intelligence or, frankly, any area of science where we're making group comparisons.
You always have to ask, how did they define the groups?
How did they define the groups, and could that be influencing the results that we're seeing?
It seems like a small point, but it's actually
a subtle point.
Really important.
But I think it's a really important one. And that kind of critical thinking is, I think, what makes someone a good consumer of information.
Right. Be critical.
Be critical. Don't just
take things.
Take things at face value.
At face value. Think about, okay, what are they really saying?
Yeah, how did they get here?
How did they get there?
What else could this mean?
Exactly.
Yeah.
And I think one of the most important tools in that regard is just understanding the limitations of statistical methods.
Right, because they're not perfect.
Yeah, they're not perfect.
Okay.
They can be very powerful tools.
Yeah, but we have to be careful about how we're using them.
So this paper is basically showing that even if you do all this complicated math,
even the most sophisticated statistical analysis can lead to misleading conclusions if you're not careful.
Well, there's that saying, right?
Yeah.
Lies, damned lies in statistics.
Exactly.
You can make the numbers.
You can make the numbers say whatever you want.
Say whatever you want.
If you torture them enough.
Right, exactly.
And I think this paper highlights a particularly important point about statistics.
Okay.
Which is the danger of mistaking statistical significance for real-world meaning.
What do you mean by that?
Yeah, so just because a result is statistically significant doesn't necessarily mean that it's important.
Right.
Or that it tells us something practically meaningful about the phenomenon that we're studying.
Right.
It's kind of like, finding a statistically significant correlation between ice cream sales and shark attacks.
It doesn't mean that one causes the other.
Yeah. It doesn't mean that one causes the other.
It just means that they're both happening.
Yeah, there's probably some other variable at play.
At the same time.
Like hot weather.
Right, like it's hot out, so more people are at the beach.
Yeah, exactly.
Eating ice cream.
More people are eating ice cream, more people are getting in the water.
And more sharks are out.
Exactly. So we have to be careful about not over-interpreting these statistical findings.
Yeah, so it's just...
And always consider the broader context.
It's statistically significant doesn't mean it's important.
Exactly. So I think the message here is it's not enough to just crunch the numbers.
Right.
We have to think about, okay.
Yeah, so what
do those numbers actually mean in the real world?
What is that?
What are the implications for how we understand intelligence?
Right.
How we educate children, how we think about differences in cognitive abilities.
The bigger...
Yeah, it's a bigger picture issue.
Picture than just the numbers.
Exactly. And I think that's one of the things that I really appreciate about this paper.
Yeah.
Is that while it is very focused on the technical aspects of intelligence testing,
it
really pushes us to think beyond just the numbers.
Yeah. To the bigger questions.
Yeah, to the bigger questions.
So what are some of those bigger questions?
Well, I think one of the biggest questions is, what is intelligence anyway?
Right.
Like, are our current methods...
Are we even measuring?
Really capturing the full picture.
The right thing.
Yeah.
Okay.
And this is a question that philosophers have been grappling with for centuries.
Right.
And I don't think this paper gives us a definitive answer.
Right. It's not going to solve all the problems.
But it definitely highlights the complexity.
But it makes us think about it.
Yeah, it makes us think about it.
Yeah.
And that's what's so interesting about it.
It's like we're so focused on measuring it that we haven't really stopped to ask.
Yeah, are we measuring the right thing?
What are we
measuring? Exactly.
Yeah.
What is this thing that we're trying to measure?
Okay.
And I think this paper is almost like challenging the foundation.
Challenging the very foundation
of intelligence research.
Of how we think about it.
Yeah. It's making us rethink our assumptions.
Wow.
And explore new possibilities.
So for our listeners who are now like really interested and want to learn more.
Yeah, where should they go from here?
Where should they go? What are some next steps?
Yeah.
I think this paper really highlights the need for more research on alternative theories of intelligence.
Yeah.
Like for a long time, the focus has been on
Right.
But maybe it's time to explore other models.
Yeah.
That might capture the full picture.
Yeah. And there's a whole world of really fascinating research out there on things like emotional intelligence, creative intelligence, practical intelligence.
I've heard of those.
Yeah, and these are areas that, like, traditional IQ tests often completely miss.
Yeah, it's like we're trying to measure the ocean's depth with a ruler.
Yeah, that's a great analogy.
Like you're going to get some information.
Yeah, get some information, but
you're missing the whole picture.
Yeah, you're missing the vastness of it all.
Right.
And I think what this paper is really encouraging us to do is to, like, develop new tools and new ways of thinking about intelligence.
Like expand how we even think about it.
Yeah, expand how we think about it.
Not just the tools.
Yeah.
But like the concepts.
Yeah, the concepts themselves.
Yeah.
And to recognize that, intelligence can manifest in many different ways.
So it's not just one thing.
It's not just one thing. It's not one size fits all.
Okay.
And I think this has really important implications for education.
Okay.
Well, if we broaden our understanding of intelligence, then we can create learning environments that nurture a wider range of talents.
So not just focusing on the kids who are good at math and science.
Yeah, not just focusing on the kids who are good at taking standardized tests.
But like being creative and problem solving.
Exactly. And helping all students reach their full potential.
It's like we're all intelligent in different ways.
Exactly.
So we need to
find ways to
find those ways.
Yeah, to support all those different kinds of intelligence.
I love that.
Yeah. And this also has implications, I think, for how we understand learning disabilities.
Right.
So if we move away from this narrow focus on BRIE and recognize the importance of these more specific strengths and weaknesses, we can do a much better job of identifying and supporting students who learn differently.
So instead of seeing those as like a deficit.
Yeah. See it as a difference.
It's just a different way.
A different way of thinking, a different way of learning.
Right. And that could be a good thing.
Absolutely.
Yeah.
And I think this brings us back to one of the most fundamental questions that this paper raises, which is...
What is intelligence?
What is intelligence, really?
Yeah, like what are we even talking about?
Yeah. Is it this single general ability?
Right.
Or is it a collection of more specific skills and aptitudes?
I don't know if we have an answer to that.
I don't know if we have an answer to that either.
Yeah.
But I think that's okay.
Yeah.
Because that's the beauty of science, right?
It's a journey.
It's a journey. It's a process.
Yeah. We're always learning.
We're always learning. We're always discovering.
Yeah.
We're always refining our understanding.
And that's what this deep dive has been all about.
Exactly.
We're not here to give you all the answers.
Yeah.
We're here to...
Spark your curiosity.
Spark your curiosity.
Make you think about things in a new way.
Make you ask questions.
Yeah.
And hopefully, go out and learn more.
Exactly.
So on that note,
yeah,
I think it's time to wrap up this deep dive.
Yeah.
I want to thank you so much for joining me.
It's been a pleasure.
This has been a really fascinating conversation.
Absolutely.
And for our listeners.
Yeah.
Thank you for tuning in.
Thanks for listening.
We'll see you next time for another deep dive.
Yeah, we'll see you next time.